This is Module 6, Lecture Notes 11. Today we're going to be talking about something called stoichiometry, and here you'll see it written out, and I've also done the phonetic spelling for you so that you can say it correctly. Stoichiometry. What stoichiometry is it's basically relating different quantities of things in a chemical reaction. So relating reactants to each other, relating products to each other, and being able to go back and forth between different parts of a reaction in the correct ratios. Okay, this is a super important topic to grasp before college. Unfortunately, we only have 2 modules, I think, really devoted to it, or 2 lectures devoted to it. There's a lot more in your book. There's, of course, so much more we could do if we had many more days on it, and this just barely scratches the surface. But definitely keep these notes for college so that you will have a foundation in what stoichiometry is. We're going to do a quick review of what we left off last week with, and that was the mole ratio, because stoichiometry hinges on the mole ratio, being able to switch from one substance to any other in a chemical reaction by using these coefficients. Remember, we said these coefficients out in front represent the moles of each of those substances in whole number ratios to each other. So the mole ratio is just a conversion step that allows you to switch from moles of what you are given to moles of what you want to find, or your unknown. Okay, so if we look at this example problem, it says, how many moles of product? This is our product. We want to know how many moles. How many moles of product can we make if we start with 9.5 moles of aluminum? And I like to write the things underneath so I can visually see I'm starting here with aluminum and I want to switch it to how many moles of product. Okay, I'd like you to take a second and set that up. This should be review from last week. Okay, so here's what I have. I started with my 9.5 moles of aluminum over 1. I don't want moles of aluminum anymore, so they go in the bottom. I do want moles of aluminum oxide, so I put that in the top. My units cancel out, and I filled in the mole ratio of 4 moles of aluminum to 2 moles of aluminum oxide. So my mole ratio should look like this. And you can even label it mole ratio. Then you're going to punch that in on your calculator, and you should get 4.75 moles of aluminum oxide for your answer. Multiply across, divide by 4. All right, next we're going to talk about something called limiting reactants and excess reactants. And I gave you a problem in your before class reading notes that had you think about how many chocolate chip cookies you could make out of some given ingredients. And that is really good to think about because a chemical reaction is just like a recipe. You have to have a certain amount of each ingredient react together to form your product. Okay, so let's think about another example together as a class. So I have 6 car bodies and I have 40 tires. These are my reactants, and I want to know out of these parts how many whole cars I can make. Well, we know that each car takes 4 tires, okay? So for these 6 cars, I would need 24 tires to react with them. Do I have enough tires? I do, okay? So I can actually make 6 whole cars. Okay, I have enough bodies to make 6 cars. I would need 24 tires. I have plenty of tires. I'm going to be able to make 6 cars. Well, why can't I make any more cars? What stops me from making a 7th car or an 8th car? What stops me is that one of my reactants ran out. And that's what a limiting reactant is. It limits the reaction. I cannot make any more because one of my reactants is completely used up. And it makes the reaction stop. I can't make any more of my product. Okay, so I'd like you to label your car bodies as the limiting reactant. The reactant that limits the amount of product that can be formed, it's used up and the reaction stops. Your other reactant is in excess. It is your excess reactant. And remember, the word excess means you have more than enough. Well, that's the case with the tires. I only needed 24, I had 40. I had more than enough tires for what I was trying to do. This is the one that you have some left over. Okay, so why do we care about limiting and excess reactants? Well, an example in real life is, let's think of a pharmaceutical company like Lilly that's based here in Indianapolis. They need to know how much of a reactant to use when making a medicine in order to make sure that they have enough to make the reaction go to completion, but also not to waste your other reactant. When you think about making things in bulk, you want to not have too much excess because think of all the money that's lost. So it is important to know your stoichiometry, to know how much you need to react together to get the amount of product that you want to form. So that's just one real life example. Let's look at another example down here in our practice problem. An iron manufacturer, so somebody that makes iron, starts with 1,256 moles of iron ore. How much oxygen are they going to need to supply to react completely with that? Okay, so this manufacturer wants to know how much oxygen they're going to need to add to get these two to react together to use all of the first product. Okay, all of this can be done using the mole ratio that we learned. Oops. So I start with 1,256 moles of iron ore, or iron sulfide, FeS2. Put it over 1. I don't want moles of iron ore, so it goes on the bottom. I do want moles of oxygen, so it goes on the top. Using the mole ratio, we're going to put our 4 with our iron ore and our 11 with our oxygen. So this tells the manufacturer exactly how much oxygen they will need in order to produce their product. Okay? I'd like you to start this second part on your own. So it says how many moles of iron oxide will be made. So now we're going to put our question mark under the product. Okay? I want you to start with your given again. But now the question is, how much product can be made? We want to switch from here to there. So go ahead and pause this and see if you can set that up and get the answer. I don't want moles of iron ore. They go on the bottom. I do want moles of iron oxide. I'm going to put 4 on the bottom and 2 on the top, and I should get 628 moles of iron oxide. Okay, so you can see that the mole ratio really helps us a lot with stoichiometry, switching from one thing to another in a balanced chemical reaction. Okay, if we flip over to the back, I would like you to take 2 or 3 minutes on your own to work out this problem completely, and then we will check it together. If a chemist adds 5.61 moles of silver chloride to excess zinc metal, the word excess means that we will have more than enough of this to see the reaction to completion. How much silver will I make? I started with my given over 1. I used my coefficients. 2 moles of silver chloride produces 2 moles of silver. Since these would simplify to 1, then I just have my 5.61 moles of silver to answer the question. Okay, the last problem we're going to work on with stoichiometry together today is going to relate products back to reactants. It works the same way. We're still going to use our mole ratio, but this kind of drives home the point of why we care about this. So let's say you're a food chemist and you work for Tropicana, okay? We need to produce some citric acid. Okay, citric acid is used in fruit drinks, jams, and jellies. The person making this wants to make 1.4 times 10 to the 5th moles of the product. They know how much they need to end up with, but how do they know how much to add to begin with? We want to know what is the amount of water they will need to add. Okay, so we can actually use the mole ratio to go backwards. It's going to be a 2 to 1 mole ratio. Okay, so here's how I would set that up. Ignore my little scribble over here. I would start with my moles of citric acid that I know I need to end with. I put that over 1. That's how much I want to make. And I'm going to use 2 moles of citric acid to cancel the bottom. Gives me 1 mole of water on the top. So I would be putting 1.4 times 10 to the 5th in my calculator divided by 2. Now this is a really good place to practice using that scientific notation on our calculators that we talked about a couple lectures ago. 1.4 second E5. Remember, I don't do times 10. I use my exponent button. And then I need to divide by 2. It should look like this. I get 70,000 moles of water. Okay, so that's stoichiometry in a nutshell. I also wanted to point out that on the front page of your notes, you may see this YouTube link printed. That is actually from Homeschool Co-op a couple years ago. So you can scribble that out, and I'm sure you will be given access to the new lecture for this year. That's all for today. Thanks.